Ecology, pyramids, energy flow and the component of ecosystem. Ecology, pyramids, energy flow and the component of ecosystem. Certainly. Let's dive into ecology and discuss pyramids, energy flow, and the components of an ecosystem. 1. Pyramids in ecology. Pyramids in ecology are graphical representations that depict the flow of energy, biomass, or numbers between trophic levels within an ecosystem. 1. There are 3 types of pyramids commonly studied. A. Energy pyramid. This pyramid shows the amount of energy transferred from one trophic level to another in an ecosystem. As energy is lost at each trophic level through respiration, heat, and waste, the pyramid typically narrows from producers, autotrophs, at the base to top-level consumers, carnivores, at the apex. B. Biomass pyramid. This pyramid represents the total biomass, organic matter, of organisms at each trophic level. It illustrates the decrease in biomass as you move up the food chain, with the highest biomass usually found at the producer level. C. Pyramid of numbers. This pyramid displays the number of individuals at each trophic level. It can be upright, inverted, or irregular, depending on the ecosystem. For example, in an oak tree ecosystem, the pyramid of numbers would be upright, while in a parasitic ecosystem, it would be inverted. 1. Energy flow in ecosystems. Energy flow refers to the movement of energy through different trophic levels in an ecosystem. 1. It follows the fundamental principle that energy cannot be created or destroyed but is transferred and transformed. 1. The sun is the primary source of energy for most ecosystems, which is converted into chemical energy by autotrophs through photosynthesis. 1. This energy is then transferred to herbivores, primary consumers, and subsequently to carnivores and other higher-level consumers, secondary, tertiary, etc. Energy flow is unidirectional, with energy decreasing as it moves up the food chain. Only a small portion of energy is transferred from one trophic level to the next, with the rest being lost as heat. This is why ecosystems typically have fewer top-level consumers compared to primary producers. 1. Components of an ecosystem. An ecosystem consists of both biotic, living, and abiotic, non-living, components. 1. These components interact with each other, forming a functional unit. 1. Here are the main components. A. Producers. These are autotrophic organisms, mainly plants, algae, and some bacteria, capable of converting solar energy into chemical energy through photosynthesis. B. Consumers. They are heterotrophic organisms that obtain energy by consuming other organisms. Consumers include herbivores, primary consumers, carnivores, secondary and tertiary consumers, and omnivores. C. Decomposers. These organisms, such as bacteria and fungi, break down dead organic matter and waste materials, releasing nutrients back into the ecosystem for reuse by producers. D. Abiotic factors. These include non-living elements like sunlight, temperature, water, soil, air, minerals, and nutrients. Abiotic factors influence the distribution, productivity, and diversity of organisms within an ecosystem. E. Habitat. A habitat is the specific environment where an organism lives and interacts with the biotic and abiotic factors around it. F. Food chain and food web. A food chain represents a linear sequence of who eats whom in an ecosystem, while a food web illustrates the interconnections between multiple food chains, forming a complex network of feeding relationships. Understanding pyramids, energy flow, and the components of ecosystems is crucial for comprehending the dynamics and functioning of natural systems. Thanks for watching.